for today, we'll be choosing how do microservices communicate. If you're new to this development game, you probably just do the internal communications via HTTP calls. But that's just the tip of it, right? To make a good system, you need to have different ways in which the services communicate. And for every system, different use case fits, different type of this communication service. So I found this document online, and let's just go through this and see how microservices communicate. Last week, I got the question on how should REST external services, and in response to update our local database and continue with our business logic. Although this task may initially appear simple and uncomplicated, based on my experience at TIDE, I have realized it far being from straightforward. This is primarily because there are numerous potential complexities and that's what I'm talking about, right? You cannot just make HTTP calls for every system. There are different methods that need to be used in case, like whatever the use case is becoming at that place. This guy is probably experienced and experienced the same. When I faced this communication, it made me the whole concept of service to service communication. Working the microservices in a distributed system like we do at Tide Engineering offers a lot of advantages. Scalability, independent development and deployments of services, tech diversity, fault isolation and resilience maintainable. That's the whole concept of microservice architecture, right? So this whole is basically how microservices basically operate. uh, they have to be built scalable होनी चाहिए, maintainable होनी चाहिए, evolvable होनी चाहिए, and then in that case, since उसमें हर एक यूज केस के लिए अलग बनाई जाती है, they have to be tech diverse, right? जहाँ पे मेरे को जो यूज केस है, I'll use that language. I'll not be dependent on one single language for that purpose. But with that, it comes with a lot of company on with service to service communication. So on these lines, I have been reading recently, like the companies have been moving towards the monolith architecture. Not necessarily that they have bundled all the services into one again, but what they are doing is key the for services that maybe have a similar kind of functionality, instead of breaking them into different ones altogether, they have just chunked them into one, because microservice architecture in itself come with a lot of burden. Now if implementing a change requires different teams to operate on the same problem itself, and that is why I think the teams are now moving towards monolith architectures and rather than microservices for the whole system. Basically, even in our company, even we did this recently, where earlier for a particular set of messaging we were having five different services, and now we have coupled all together into one because they all had the same functionalities. Instead of bringing change into five different services, we just need to change that one now. Okay. Moving forward, right? What is S2S communication? Service to service communication refer to the interaction and exchange of data between services in a distributed service. Okay. In a microservice architecture, each service is responsible for a specific business capability and can operate independently. However, to fulfill complex requirements, service needs to communicate with each other in exchange data triggers. Mhm. Okay, so basically, microservice architecture, how they communicate, basic exchange of data that goes on, and the things about it, why and when to use this, when do you want to use the service to service communication. Basically, you want to send some data or perform an action from the other microservice, and that's where you use this microservice service to service communication. But just to go through it, microservices need to work together to accomplish a business goal. Service needs require data the services to perform its tasks. For example, an e-commerce service may need to communicate with payment, inventory management, and service to process an order. Services play a role of consumers need to react upon hearing event. Okay. Services communication needs to be load balanced. Services are designed to be loosely coupled, allowing independent scaling. And okay, these are all. So basically, this here he has mentioned what microservices are needed for, and basically what kind of operation do we perform with these microservices, right? More on why we should use it, separation of concerns and modularity, because each microservice should be designed to be self-contained and focus on specific business capabilities. S2S communication enables the service to exchange data, helping the system polyglot programming. Each service will be implementing the most appropriate technology for its own requirement. That's what I was saying, right? Microservices क्यों helpful रहती हैं? Because they help in implementing, because we can implement, like if you are supposedly you are in let's just suppose you are a legacy company and you are now introducing AI, but all the code has been written in Node or maybe some other language that does not support the AI capabilities. But since Python is the one, you'll make another microservice and then you'll just do it in Python so that you have the proper AI capabilities, right? You are not compromising on any performance or anything. So types, let's just dive into what types of S2S communication are. Microservice architecture often involve a combination of multiple communication patterns based on specific requirements. Okay. Okay, so let's just go by first. Synchronous HTTP REST API calls, a simple, widely opted, and suitable for many my inter-service communication scenario approach, allowing for communication over HTTP using the REST API architectural call. To achieve it, the service produces data exposed well. Okay, so it's basically making HTTP requests, but not to an external system, into your localhost services, right? It can be on the other clusters as well, but it's majorly a local host itself. Basically, what we call them in corporate is internal API calls. But there also comes a problem with these come with their own burden. If you start using too much of the bandwidth internally, it will cause problems for the services that are being used by the external dashboards, right? So if there is any service that is opening HTTP threads via the external dashboard, it will have a late response because it has already enough number of threads being opened by the internal communication itself. So that comes within its own debt. Synchronous API calls, asynchronous messaging, a more complex way. This is basically, he talks about the event driven architecture. That is basically you throw in the event and then it is being taken care asynchronously. It's not being done synchronously. Basically, the event driven architecture, there where you send in the data to the queue, they send it to further lambda, or they can trigger an ECR or whatever they want with it. So that is the kind of so that is what this asynchronous messaging. RPC and service mesh. RPC and service mesh. Going through RPC services invokes methods or procedure exposed by other services over the network, making it appear as if they were local method calls. RPC frameworks handle the underlying network communication and serialization and deserialization of data. Such frameworks are gRPC or Spring Cloud Network Spring. So the to give you a example where you can understand it better, let's just say I go to a restaurant and order food, right? And the waiter takes the order, goes to the chef, places my order, and then the waiter brings back the food with me. So in this case, I'm the client, the waiter is the RPC framework, and the chef is the server who is fulfilling my request. Now you can link it to any system and then you'll have your RPC framework itself. Service mesh is another kind of S2S communication infrastructure which uses a sidecar proxy pattern which handle all the common operations like load balancing, service discovery, security, observability, and traffic management. This shows basically sidecar proxy shared by all the services in itself. Now we have is database replication. Database replication basically is where each of the microservices have their own database. Uh, where each of the microservices have their own database, but the other microservices use the string connection string of those database as well, so that they do not need to make synchronous API calls. But this causes when it synchronous communication preferred the use of events, security and authorization, real-time interactions, ease of use, and request response interaction. So basically, HTTP calls का कब use करना है? Basically, when we have to validate every request that is going in, that is security and authorization, and real-time use, that is basically where we need updates in real time. Just suppose you have a messaging system wherein you want one-to-one messaging. So until and unless there is an API request with a response from the maybe the AI server, you do not want the user to send another message. That will be another API call. So that is one basically real-time communication. Next, he explains here work with S2S communication. This is I'll leave up to you guys. So go check this out. I'll link this document in the description. Go check this out. It's an if you're doing service to service communication, this document might help you a lot. Other than that, this was my first video. Do like, share, and subscribe, and hit the bell icon to get an update as soon as I post the next video.